use the following tables to find exponential models of the given data. And so the exponential model is generally written as f of x is equal to a times b to the x. So we're told to find an exponential model, which means we are expecting this. Now, when we have an exponential model, each time the input changes by 1, you would be multiplying by the same constant on the outputs. So notice to go from 20 to 60, I can multiply by 3. And from 60 to 180, I can multiply by 3. And 180 times 3 is 540, and 540 times 3 is 1,620. So these data points do fit an exponential model. And so notice that we have 20. We have 20 times 3. We have 20 times 3 to the second. And we have 20 times 3 to the third. And we have 20 times 3 to the fourth. And 3, of course, is 3 to the first. And we have 3 to the 0 here. And so we see the exponential pattern, and I would write that f of x is equal to 20 times 3 to the x. In our second table of data, we're again told to find an exponential model. So again, we're looking for something of the form f of x is equal to a times b to the x. This one's a little tougher. It isn't obvious how I would get from 25 to 30 and 30 to 36. And so what I'm going to do instead is I'm going to kind of go in the other direction. I'm going to ask myself, 25 times what is equal to 30? And so dividing by 25, that what would be equal to 30 over 25, which is 1.2. And let's just check that. What's 30 times 1.2? 30 times 1.2 is 36. What's 36 times 1.2? 43.2. And let's just check that last one. 43.2 times 1.2 is 51.84. So what I see here is that 30 is 25 times 1.2. 36 is 25 times 1.2 squared. 43.2 is 25 times 1.2 cubed. And 51.84 is 25 times 1.2 to the fourth. And again, we have 1.2 to the first, and we have 25 times 1.2 to the 0. So we would have the function f of x is equal to 25 times 1.2 to the x. Alright, in our third table, we're again asked to use the table to find the exponential model. So notice our inputs aren't increasing by 1s now, but rather by 3s. And that we can work with that as long as it's still consistent. Now, how would we get from 32 to 800 and 800 to 200 and 200 to 500? You might be thinking here, we'll just divide by 4. Well, when we have an exponential model, we don't like to think division. We like to think multiplication. So to divide by 4 is the same as multiplying by 0.25. Right? Dividing by 4 is equivalent to multiplying by 1/4. So notice that 800 is 3200 times 0.25. And 800 times 0.25 is 200, so that's 3200 times 0.25 to the second. 200 times 0.25, so 3200 times 0.25 to the third. 3200 times 0.25 to the fourth. We have a 0.25 to the first, and of course we have 3200 times 0.25 to the 0. Okay, but now wait a second, we have to be careful here. Look at our inputs. We need 0 to go to 0, 3 to go to 1, 6 to go to 2, 9 to go to 3, and 12 to go to 4. And so now, how would you take all of those inputs and go to those exponents? You would have to divide by 3, or multiply by 1/3, however you want to think of it. And so what I can write here is that f of x is equal to 3200 times 0.25, but not to the x, but to the x over 3. I would have to take the input, divide it by 3, and that actually gives me the exponent on the base 0.25.